Guys, today we're going to talk about plate boundaries, and to begin we need to go ahead and make a foldable. So if you would get a piece of, you're going to need a piece of white, plain white computer paper, you're going to need a pair of scissors, and you're going to need a yellow, pink, and green highlighter, so as well as your pencil. So go ahead and get those things. Then when you're ready, you can go ahead and fold this paper in half hamburger style. If you would, go ahead and fold it in half hamburger style, and then you're going to open it up, and then you're going to cut 3 equal parts. You're going to cut 3 equal pieces, so that you have room to write each of the types of boundaries on there. Go ahead and turn it sideways like this, up and down. So you should have 3 flaps now to open up and complete this foldable. So on the top one, you're going to write the first type of boundary, which is a convergent boundary. Convergent boundary. Alright, so the first one's going to be a convergent boundary. The second one is going to be yellow, and that's going to be what we call a divergent boundary. So it's going to be D-I-V-E-R, divergent boundary. Okay. And the last one is going to be, the bottom one is going to be in green, and that's going to be a what we call a transform boundary. Transform boundary. Transform boundary. Okay, so now we're ready. Let's go ahead and talk about what makes each of these types of boundaries. So if you will, let's look at the first one, which is the convergent boundary. Open up the flap, if you would, and we'll go ahead and record the information inside. A convergent boundary is one where the two plates that are side by side are coming together, or they're colliding. So we've got 2 plates and they're moving toward one another. Okay? We've got come together, or we could say that they collide. And the way that we remember this is the CO is consistent with convergent. Both convergent and come together and collide, all 3 of those start with the same 2 letters, CO. So that's how we remember that convergent is the plates that collide or come together. So there's 3 different situations that we can look at when we're talking about convergent boundaries. We've got 2 pieces of 2 plates, 2 tectonic plates, where they're continental and continental, continental and oceanic, or oceanic and oceanic. So what I need you to do first, before we start recording our information, I need for you to go ahead and divide this into 3 equal parts. So that's not very equal, but we'll go ahead and divide it anyway. Try to make yours as equal as possible. The first one is going to be continental and continental, 2 continental plates. That would be like the African plate colliding with the Asian plate. And where we have this kind of collision taking place, we have mountains being created. So we have that upward movement of continental crust over here, and continental plate over here, and a continental plate over here. This might be the African plate, this might be the Asian plate, and when they collide or they push together, they collide and mountains are created. Okay, so where we see mountains, some of those mountains were created by two plates colliding. The second type that we have, the second type of convergent boundary, is a continental plate colliding with an oceanic plate. Okay, so in this one we've got a continental plate and an oceanic plate. That is, when they collide, again, they do collide, but the oceanic plate, because it's denser or more dense than the continental plate, it takes a dive. When they hit one another, there's a hole that's created right here, because when they collide, the oceanic plate, this is the oceanic right here, because it's more dense, it's going to dive underneath the continental plate. The continental plate is less dense, so this is where we have volcanic mountains, and I'm going to draw a little triangle here with something spewing out of it, because that's where we have some volcanic activity right there. So what this does is it creates a trench, which is an opening in the ocean floor, or just an opening wherever it meets, wherever these two collide. The oceanic crust is going to dive underneath the continental crust because it's so much more dense. It's going to do the diving. So we've got volcanic mountains and trenches that are formed through this. So volcanic mountains and trenches. Now, the third type that we've got, this is like the Himalayan mountains. The continental would be where the Himalayan mountains were formed, because that's a piece of continental crust colliding with another piece of continental crust. And then the continental and oceanic would be like the Atlantic plate colliding with, this would be the oceanic, the Atlantic plate, the Atlantic Ocean, sorry, and the African plate, or the African plate. That would be continental. So you've got volcanic mountains there, and you've got some trenches that we'll show you in another video. The third type is oceanic, an oceanic plate colliding with another oceanic plate. So of course this is going to take place underwater, strictly underwater, because you've got two oceanic plates. Now you've got another situation where you're going to have one dive beneath the other one. The more dense plate is going to dive. The less dense plate is going to stay and just slide where it hits the more dense oceanic plate. Then it's going to stay this parallel to the ground. This one is going to dive deeper. In this case, you have trenches again are formed, but you also have volcanic islands that are formed. In this case, this would be Hawaii. Okay, Hawaii was formed from two oceanic plates colliding, and one subducted under the other one. The denser subducted, the other one stayed more level, but it eventually, because this pushed underneath, it pushed this up, so you've got the land being pushed further up so that you can actually see the islands that are formed. Now, I said a word just now, and I wonder if you caught it, the word subduction. Sub means under, We talked about prefixes the other day. These are both subduction zones. And when you've got subduction going on, you've got one plate diving underneath the other. This is what you call subduction, when you've got one plate diving under the other one, because the prefix sub means under. Okay, we'll go into more detail later once we get further into this. But if you have any questions, you can feel free to call to ask either one of us, and we'll be able to answer you. So that's your convergent boundaries. You've got continental crust, meeting continental crust in a collision, or you've got continental crust or continental plates colliding with oceanic, or you've got oceanic plate colliding with oceanic plate. So let's close that and let's move on to the divergent boundary. The divergent boundary is one where you've got die, the prefix die means apart or away. So when you've got that prefix, you've got divergent, which means it's moving away. So we're going to write move away from each other. This is where the plates move away from each other. Okay, they're separating. I'm going to also put move apart. Okay, moving apart. Showing this, we're going to do two arrows going in opposite directions. And in this one, in this example, we've got two kinds of boundaries. And one of them is continental plate, separating from another continental plate. And what we're going to do, this is where a rift valley is formed. You've got a rift valley. A rift valley. So you've got this plate, you've got a continental plate here, separating from a continental plate over here. And you've got this rift valley being formed. Okay, so there is an example of a rift valley in Africa. Gosh, I can't remember the name of it, but it's easy to look up. All you have to do is search rift valleys, tectonic plates, and you can definitely find an example of one while you're at your stations. The second type of plate boundary that's considered divergent is the oceanic. Two oceanic plates pulling away from one another. Okay, so you've got oceanic plate pulling away from oceanic plate. Got your oceanic over here, and you've got your oceanic over here. And they're both pulling away from one another, creating an empty space. Well, when you're on the sea floor, when you're on the ocean floor, you're getting closer to the mantle of the earth, which is where it's going to get hotter. It's going to get more volatile down there. So you've got magma that's pushing up out of this open space. So I'm going to draw three little arrows showing the magma being pushed up. Okay, you don't have a bunch of volcanic action in this case. You have more just magma seeping up. You know, it's kind of like opening up, and it's slowly bubbling up to the surface. So this is what we call seafloor spreading. It's where the floor of the ocean is spreading out. It's pulling away from each other. Or what it creates is a mid-ocean ridge. There's an incredible mid-ocean ridge in the Pacific that we'll also show you an example of. It also creates ocean basins. Okay. And again, we'll show you examples of those as we go along in here. So oceanic and oceanic plates spreading apart allow magma to seep up, and it causes seafloor. That's what seafloor spreading is, and it causes mid-ocean ridges to form and oceanic basins to form. So if you will, go ahead and shut that window, and we'll open up the transform boundary now. We'll go ahead and open up the transform boundary, which is our last type of boundary we're going to talk about today. Now, the transform boundaries are where two plates are not colliding and they're not pulling apart. They're actually sliding past one another. So we're going to go ahead and say slide past each other. Okay, we've got one going this way, we've got one going this way, and right here, this is called shearing. When we have that movement, we have one going one direction and one going that way, but they're rubbing against one another. It's called shearing. S-H-E-A-R-I-N-G. This is where a fault is created. You guys are probably familiar with the San Andreas Fault in California. It was on that movie, I can't remember the name of it, that The Rock was in, Dwayne Johnson. So that is the San Andreas Fault, and that was caused by two continental plates sliding past one another in a transform boundary. This is also where earthquakes this is where earthquakes happen. I'm sorry, I had a brain freeze. Earthquakes happen at transform boundaries, as well as tsunamis. Tsunamis are when they happen underwater. Okay, this is more continental, on top of the earth or on top of the crust. This is more oceanic. The tsunami, when an earthquake happens underwater, this is what's caused a tsunami. So that's again caused by the two plates rubbing against one another and causing that friction right there. So if you will, go ahead and close this now and get your journal. You're going to need to turn to page 9. This is going to need to go on page 9. And we're going to write at the top plate boundaries. Plate boundaries, and we're going to glue it in on page 9. So glue it, and you are done for today, or for this lesson. All right, thanks for listening.